Hi everyone. In this session we're going to be talking about study design, and this is the first of two sessions where we're going to be doing this. In this particular session we're going to be covering exploratory research and observational design. Don't forget to check your to-do list. Make sure you're reading the chapter, looking at the articles that need to be read for this week, and also taking a look at the video. There's a video that's embedded in this PowerPoint, but it's also available as a link through the Blackboard folder. And then there are a couple activities within the PowerPoint that we're going to cover as well. All right, so let's get started. So before we really start talking about study design, I just want to quickly discuss the difference between incidence and prevalence because they are somewhat related to study design and analysis. In fact, some types of study design are actually called prevalence studies. Incidence and prevalence are really epidemiological measures for morbidity frequency. So morbidity refers to illness, while mortality refers to death, so don't confuse the two terms. Incidence characterizes disease risk, the number of persons in a population who become ill, and describes the occurrence of new diseases within the population. Prevalence, on the other hand, describes the number of people who are ill at any given time. Therefore, it describes existing cases of the disease. We may say the prevalence of diabetes in the US is 9.4% of the population, meaning 9.4% of the population have diabetes. Incidence is related to new cases of a disease. We might say there are roughly 1.5 million new cases of diabetes each year. Therefore, this number is related to the incidence of diabetes. Click on the video icon to watch a short video on how to calculate incidence and prevalence. If for some reason the link isn't working, I've provided the video in the PowerPoint links and activity folder for this session. What is observational research? Can you provide an example? Take a minute and write down your answers. Studies may be considered observational because in observational studies, the data is not manipulated. Rather, the data is collected as they normally exist. Generally, observational studies involve the gathering of information from a natural state. By natural state, we mean that an experiment has not been performed. Observational studies can be descriptive or exploratory. For now, we're really talking about exploratory observational research. Exploratory studies research the relationship between variables, or more specifically, the relationship between the independent variable, the predictor variable, or the exposure, and the dependent variable, the outcome, or what we might often say, the disease. Exploratory studies can be retrospective. This is research of data collected in the past, or prospective. A researcher would identify variables and then would be able to actually measure the exposure and the outcome in the future. They may also be longitudinal or cohort, which is following people over a period of time. An example of an exploratory longitudinal cohort study is the Framingham Heart Study, which began in 1948 with over 5,000 subjects. At periodic intervals, subjects are sent a survey and asked to answer questions, and then laboratory and anthropometric data are also taken. And I should note that the Framingham Heart Study is in different phases, but it's still ongoing today. Cross-sectional studies are another method of observational research. A cross-sectional study generally includes a small subgroup of a larger population. This group is then typically selected only based on inclusion and exclusion criteria, and then they're observed at one specific time to assess exposure and outcomes. Let's take a look at these and other types of observational studies. Retrospective studies are conducted at the present time when the researcher decides the variables to analyze. So both the exposure, the independent variable, and the outcome, the dependent variable, are assessed retrospectively. The researcher then reviews previously collected data, such as medical records, previously collected surveys, etc., to analyze for these variables or to look for these variables. For example, previously collected data in the form of employee health records could be used to retrospectively track someone who has an outcome to see if they have experienced the exposure. The key in a retrospective study is that the exposure and the outcome have already occurred. A prospective study occurs into the future. Here, the exposure is defined and the outcome has not yet occurred. Researchers are watching for the outcome, the disease state, in the study sample. Longitudinal research is a study of a specific cohort over a period of time. Longitudinal research can be retrospective or prospective. Data in a longitudinal study is typically collected in a specific time sequence, which allows for the observation of patterns and can help determine if the patterns change over time. Longitudinal studies can help suggest a causal relationship between an exposure and an outcome. Although the longitudinal study can suggest a causal relationship, it cannot determine true causation. Longitudinal studies can provide evidence of the direction of the relationship and the magnitude of change. For example, is there an observed change in weight based on the amount of sugar-sweetened beverages consumed? Is a higher amount of sugar-sweetened beverages related to greater weight gain? If yes, this describes the magnitude of the effect. Therefore, longitudinal studies can help identify patterns and can help determine patterns of change, the direction of the change, as well as the degree or the magnitude of the change. There are many advantages of longitudinal studies. Advantages include the ability to determine a possible link between cause and effect. Again, it can't determine true causation. Longitudinal studies can provide a wealth of knowledge and understanding of the relationship between variables and the impact on human health. Disadvantages of longitudinal studies include that they're very costly. There's also a long-term commitment on behalf of the researchers and the participants. And because the study is long-term, there's a potential of dropouts. This could decrease the sample size and the amount of data collected, making it difficult to determine relationships. In retrospective longitudinal studies, the outcome and the exposure are identified in the present time, and the researcher follows information through historical records. In prospective longitudinal studies, information is followed into the future. Exposure and outcome are identified, and the study population is followed for those variables. Let's take a brain break. Find the name of two large nutrition-related longitudinal studies. Are they retrospective or prospective studies? Welcome back. Cross-sectional studies are also considered prevalence studies, as the disease state occurred or did not occur at the time of the study. Remember that prevalence measures the number of people with the disease at a particular time, and incidence is the measure of newly diagnosed cases. Cross-sectional studies can't measure newly diagnosed cases, only those that are occurring at a specific point in time. An example of a cross-sectional study might involve determining a health literacy score by survey and at the same time, use of an oral glucose test to determine if someone has type 2 diabetes. Here, the researcher may look to determine if there is some correlation between health literacy score and type or status of type 2 diabetes. Perhaps the researchers are thinking those who have lower health literacy scores have a greater chance of developing type 2 diabetes, and they're looking at the association between those variables. Cross-sectional studies can help identify correlations but can't determine a cause and effect. However, they are often the first step in identifying how exposure and outcome are related. This is a pictorial display of a cross-sectional study. When the data is collected, researchers would look at those who are exposed and not exposed and then determine who of each group developed the disease. Advantages of cross-sectional studies include the relative quick nature of the study. Exposure and outcome are measured at the same time. Cross-sectional studies are often less expensive than other studies, and in addition, there is no loss to follow-up as all the information is collected at the same time. Disadvantages include non-response bias, and that means that those who consent to participate may differ from those who do not participate. Therefore, the sample may not truly be representative of the general population, and this limits the generalizability of the results. You also can't determine the temporal relationship or the time sequence of the exposure to the outcome. Because you can't establish this, the cross-sectional studies really cannot determine causation, only association. Take another quick brain break and find a cross-sectional study related to your research topic. Determine what is the exposure and what's the outcome. Correlation studies look at the degree of association between variables and ask to what extent does one variable vary in relationship to another variable. To measure the strength of a relationship, a statistical test would be run, and this would also help us determine the magnitude of the effect. We're going to talk more about statistics in the coming weeks, so don't get too caught up in that. Just as with other studies we have discussed thus far, correlation and prediction studies cannot determine a true cause and effect. They also cannot be used to test the difference between groups. That is to say, we can't use these studies to see if one group performs better than another. Caution must also be taken when interpreting this type of exploratory study. Confounding variables may underlie strong correlations. For example, there may appear to be a strong correlation between health literacy scores and type 2 diabetes, but another variable, such as access to healthy food, may play a factor in health literacy scores and type 2 diabetes. Only when this other variable is controlled for and/or tested for will we see a true picture of the relationship between health literacy and type 2 diabetes. While correlation studies look at the relationship between variables, predictive studies look to predict a behavior or response based on the relationship. For example, based on a person's health literacy score, can we predict how well they will be able to maintain a stable A1C goal? Prediction studies are often used to predict how someone will score on a survey or questionnaire. Multiple regression, a type of statistical test, can be used to create an equation that factors in variables and predicts the difference between the observed and the expected values. We're going to talk more about multiple regression in the coming weeks, so don't get too caught up in that yet. Theory testing involves developing a hypothesis of what is thought will happen in a study. Then the study works to test the hypothesis. For example, researchers hypothesize that participants' scores on a health literacy test will be related to literacy or specifically reading level. Researchers then examine the relationship between health literacy and reading level to see if the theory can be proven or disproven. Case control studies look to determine if there's an association of an exposure with a disease. The expectation would be that the exposure would be higher in those with the disease, the cases, than in those without the disease, the controls. Case control studies are used retrospectively as the outcome has already occurred. Researchers attempt to track subjects through records to find out exposure histories. The theory is that exposure equals outcome. The difference in exposure histories between cases and controls will explain the prevalence of the outcome. Advantages of this type of study is samples are easier to gather. You're using records versus using actual people. Also, since you're looking back retrospectively, there's no need to wait long periods of time for the disease to occur. Disadvantages include uncertainty with the relationship between the temporal exposure and disease, and because of this, you can't generalize as the population of cases and controls may not represent the general population. An example would be a study to determine the relationship of smoking to coronary heart disease. This slide depicts how a case control study, which looks at this relationship between smoking and coronary heart disease, would be organized. We would look at cases of coronary heart disease and controls, those that don't have coronary heart disease, and then look back through the records to determine who smoked and who did not smoke within both groups. Incidence cases equal newly diagnosed cases, and prevalent cases equal those who have had the disease for some time. When selecting cases, you can use incident cases or prevalent cases. Cases can be selected from hospital patients, patients and physicians' practices, clinical patients, registry of patients, and a number of different areas or a number of different records. If cases are taken from a single source, there is a risk that the results won't be generalizable as the sample may not be representative of the general population. There are pluses and minuses to using incident or prevalent cases. If you use prevalent cases, they may be biased by survival, meaning risk factors may be more related to survival of the disease than development of the disease. If you use incident cases, you'll need to wait until additional cases are diagnosed. The selection of controls is very important. Controls should have the same personal characteristics as the cases and represent the same population. It's important that cases and controls represent the same type of population and are representative to general populations if you want to generalize the results. Otherwise, the results can't be generalized and are only representative of the population under study. Problems can occur with case control studies. Sometimes it's difficult to determine the dose-response relationship between the outcome and the exposure. This is how much of the exposure causes the outcome. Another issue may be determining if the disease is caused by the exposure or something related to the exposure. For example, a case control study by McMahon et al. Showed a relationship between coffee and cancer of the pancreas. But the question remained as to whether the coffee caused the cancer or was it something related to coffee consumption, maybe smoking. There are many types of bias that may impact the analysis and results of a case control study. Review this slide to understand some of these bias. This slide also includes types of bias. misclassification warrants a short discussion. Misclassification means subjects are misclassified on exposure or outcome, and this means they are put into the wrong group. For example, if those who have the disease are put in the control group and control participants are placed in the cases group, this leads to non-differential misclassification. If this is done randomly and equally, it in turn will lead to a minimization of the relationship between the exposure and the outcome, so we won't see the true effect. If the misclassification is unequally distributed, then we may see under or overestimate in the relationship. And we see this type of misclassification particularly in self-reported food consumption, when people over or underreport a particular pattern in eating. Cohort studies are also known as follow-up studies. Here, researchers select the subjects because they don't yet have an outcome. Subjects are continually interviewed for exposure and examined at multiple time points for the outcome. As I mentioned earlier, the Framingham Heart Study is a longitudinal cohort study. This study allowed researchers to evaluate patterns and predictive factors. While it began as a heart study, it has been expanded to include factors related to disability, stroke, back pain, and more. Participants in cohort studies are outcome-free or disease-free at the time of selection. They are then followed up over time to determine exposure and the outcome. Cohort studies can determine a temporal sequence because both the exposure and the outcome are determined during the course of the study. The basis of the cohort study is comparing exposed and non-exposed people and can be both retrospective and prospective. A retrospective study occurs when the investigator studies individuals who have already been exposed to risk factors and have already developed the disease. In a prospective cohort design, the researcher contacts the subjects before or after study, but definitely before the disease develops. Cohort studies tend to be large to allow for a sufficient number of subjects to actually develop the outcome. Cohort studies also tend to be large to allow for loss to follow-up. When selecting subjects, it's important that they come from a population that has a potential of developing the disease. You wouldn't want to select women who have had a hysterectomy if you want to follow up for the development of uterine cancer. There are many issues with cohort analysis, and misclassification of exposure and outcome is just one of them. Bias is not generally a concern in this type of study, as the classification of exposure and disease are independent of each other. There may be response bias because the study includes multiple measures over time and participants may learn how to answer questions. There could also be perhaps some selection bias because those who choose to participate may be different from those who don't participate. Because the study is ongoing, dropout or attrition is a huge concern. Researchers must make every attempt to determine if attrition is in any way related to the exposure of the disease. Cohort studies also really require great communication. Remember that participants are coming in for multiple follow-ups. The Framingham Heart Study has been ongoing since 1948. You need great communication to maintain contact with those people. Cohort studies can't determine a cause and effect. However, they can provide strong evidence of a cause and effect relationship. They can determine in some instances the temporal sequence, which is the time sequence of exposure preceding outcome. They can also determine the strength and the magnitude of the association. They can also help determine the biologic credibility, which means that the researcher is able to suggest a mechanism by which the exposure caused the disease. A cohort design can also determine consistency, meaning it can help support the research of others in the same area. And finally, a cohort design can help establish the dose-response relationship, meaning it can help determine the severity of a disease related to increases or decreases of exposure. Methodological research involves studies designed to help measure assessment tools and assessment instruments. This type of research can help determine which tools are effective in measuring outcomes. Two terms we discuss in relationship to measurements of tools is reliability and validity. These terms, though similar, are actually quite distinct. Reliability refers to the consistency or repeatability of a result from the use of the tool, while validity references how well the tool is able to measure what is intended. Finally, I'm going to wrap up this presentation with secondary data analysis. For your master's thesis, you may decide to conduct a study using secondary data analysis. This type of analysis uses existing data or databases to re-examine variables. This allows for the study of the relationship between variables not originally thought of by the researchers. There are advantages and disadvantages to this type of research. Advantages include minimal expense as the work to collect the data has already occurred, and disadvantages may include lack of control over how or what data was collected, as well as the quality of the data. Secondary data analysis can occur by finding a question to fit the data or finding the data to fit the question. Either approach works. Some sources of secondary data in nutrition include NHANES, BRFSS, or YRBSS. These are large surveys that take place. Are there any other secondary data analysis sources that you can think of? For this final activity, you will need to search the literature for a cohort study related to your research topic. Examine the study and determine if it's retrospective or prospective. Decide what the exposure and the outcomes are. Then decide if this article will be included in your research for your literature review. This is where I'm going to end the presentation. Be sure you read the chapters and any other assigned readings. Complete all the assignments and activities that are due this week. And if you have any questions about anything, don't hesitate to reach out to me as soon as possible. Thanks so much and talk to you soon.